Trigonometric substitution, otherwise known as trig sub. Integrals involving a squared plus x squared, a squared minus x squared, or x squared minus a squared. Usually these are in a fraction, but not always. These can sometimes be found using a right triangle and a simple trig substitution. Recall the Pythagorean theorem, which says that a squared plus b squared equals c squared in a right triangle, or a squared equals c squared minus b squared. Notice that those two setups are very similar to what we have up here. I'm going to try to do this using 3 problems and doing all 3 simultaneously to show the differences as well as this basic process. Here are the steps. Number 1, set up a triangle. So after we write the problem down, we're going to draw a right triangle and we're going to label it. How do we know what to label it? I'm going to look at the bottom here and I see 16 plus x squared. Well, since we know the right triangle, what has to be the sides of this triangle? They are going to be, the legs will be 4 and x, and then we'll be able to figure out what the hypotenuse. It either could be 4 here and an x, or it could be 4 and x, and we can have it switch. How should we know which one to do? If we follow one simple rule, we will get it every time. If we can, put the x on the vertical leg. So here's x, and that would make this 4. And if we apply the Pythagorean theorem, we'll get that this would be 16, square root of 16 plus x squared. Now let's take a look at the next one. We have 4 minus x squared. Again, Pythagorean theorem, when we have 4 minus x squared, this 4 part has to be from the hypotenuse. So that's telling us that the hypotenuse will be 2. And again, it could be either leg, but we want the variable x, if we can, on the vertical leg, and therefore the bottom will be, using Pythagorean theorem, 2 squared minus x squared, square root of. Looking at this one here, we have x squared minus 9, just like over here where 2 was the hypotenuse. Now we're looking at x as being the hypotenuse. So we'll put x there, and since the side 3, let's put that on the horizontal. If we can put it on the horizontal, let's do so, and that will allow us to solve for this side and put x squared minus 9. So as long as we remember that if there's a choice, we want just x on the vertical, and if the x is on the hypotenuse, then we would want the square root of an x squared minus whatever that is on the vertical. Now let's label theta here. So step 2, define a trig function to have x on the top and not the square root. So what would that be here? We want x on the top and we don't want the square root, so we're going to be dealing with theta, and we have the opposite side and the adjacent side. So that would be tangent theta equals x over 4. Now try to do it for the next one. What's going to be dealing with theta, x, and 2? Opposite and hypotenuse, that one will be sine theta equals x over 2. And when we look at the last one, which one is going to deal with hypotenuse? And then 3, hypotenuse over adjacent. Well, that's very similar to adjacent over hypotenuse, which is cosine, but this will be the reciprocal. So it is secant theta equals x over 3. Now let's solve for x. So x will equal 4 tangent of theta, and multiply by the 2, so we'll have 2 sine theta equals x, and we have 3 secant theta equals x. Now remember, we're doing a substitution. We're trying to integrate this using this method. What we're going to need to do is get rid of everything. We're going to need to get rid of the 16 plus x squared. We need to get rid of the dx. We have x. Let's find dx. What's the derivative of tangent, that'd be secant squared theta times d theta. The derivative of sine, that would be cosine theta d theta. That will equal dx. And what's the derivative of secant? That would be secant theta tangent theta d theta equals dx. Let me slide this up to have a little bit more room. Now what? Step 3. What we're going to do is proceed to integrate. I was just briefly going over these ideas. What do we need to do? We need to find dx. We've done that. We need to find an expression for x squared plus or minus whatever that number is with this square root from the triangle. We will substitute the trig stuff into the integral, and then the last will be to integrate. All right, so let's take a look. We've already found what dx is, so that part's good. 3 is a constant, we can just take that out. We need to have an expression for 16 plus x squared. Well, what we'll deal with, again, so we're going to look, where do we have 16x squared? Here's the square root over 4, and which trig function deals with that? That would be secant theta equals the square root 16 plus x squared divided by 4. And if we multiply both sides by 4, we get 4 secant theta equals the square root of 16 plus x squared. Now, is that what we have in our integral? No, we have just 16 plus x squared, so we need to square both sides. So we'll have 16 secant squared theta equals 16 plus x squared. How would that look when we go into our substitution? Let's take out the 3. Now we have dx. What is dx? That is 4 secant squared theta d theta. And what does 16 plus x squared equal? That equals 16 secant squared. So we have 16 secant squared theta. And that will simplify. The secant squareds go away. 4 over 16 would be 1/4. So we're left with 3/4 integral of d theta. Let's set up the other ones, and then I'll come back and finish this. We need an expression for the square root of 4 minus x squared. So we'd want that side as well as the 2. And what's going to deal with that? That would be cosine. Cosine of theta will equal adjacent 4 minus x squared divided by 2. So 2 cosine of theta equals the square root of 4 minus x squared. And in this one, we don't need to worry about it because we have that square root, so there's nothing to do. We don't need to square it. So when we substitute in this time, let's take out the 5 as well. dx, what does dx equal? 2 cosine of theta d theta. And the square root is 2 cosine theta. So that gives us just 5 times the integral of d theta. It doesn't always turn out to just give us d theta. Let's look at this one. We want to get rid of this square root. Which trig function deals with theta, the square root, and the 3? Because we want the constant in there. So we have tangent theta equals the square root x squared minus 9 over 3. So we have 3 tangent theta equals the square root of x squared minus 9. Substitute that one in. Let's take out the 7 again. And the top is dx, so we have 3 secant theta tangent theta, d theta, divided by 3 secant theta. And that one will be left with 7 integral of secant theta d theta. So let's finish this. We'll have 3/4 theta plus c. This will be 5 theta plus c, and I'll hold off on that one. Now, our problem didn't have theta in it. Our problem has x's. Well, what is theta? We can go back here where it says tangent of theta equals x over 4. So what will theta, if we solve that equation for theta, theta will be the inverse tangent of x over 4. Now, we've done problems like that before. This has given us another method to do it, as well as we can now solve harder problems. What is theta in this one? We go back to sine theta equals x over 2. So theta equals the inverse sine of x over 2. And then plus our constant. Now, we need to figure out how do we integrate secant theta. We did this for a homework problem way back when. It requires a careful multiplication. What we're going to multiply it by is secant plus tangent over secant plus tangent. Why? What happens now when we do this, we get secant squared theta plus secant theta tan theta, and then we'll have a d theta, all over secant theta plus tan theta. If we say let u equal secant theta plus tan theta, then du is secant theta tangent theta plus secant squared theta d theta. And note that's exactly what we have on the top, so that becomes du over u. And how do we integrate that? That would be 7 times the natural log of the absolute value of u plus c. So that would be 7 times the natural log of secant theta plus tangent theta plus c. Now again, are we done? No. We have to say, we weren't asked to find in terms of theta. We were asked to find this problem, the original one, has only x's in it. We did a trig substitution, and then we had to do a regular substitution. What is secant theta? We can come back up here, and we know that secant theta is x over 3. So this becomes ln of the absolute value of x over 3 plus, what's the tangent of theta? That is the square root of x squared minus 9 divided by 3. Close, plus c. Now there are various different forms. If you were going to try to do this and type this original problem in on your TI-89 if you have one, it probably will not give you this answer. But remember, if you have two antiderivatives of a function, of a same expression, they differ by at most a constant. So it would be possible to, using our rules for ln, to manipulate it and show that you really do get the exact same thing. And that's it for trig substitution as far as doing the basics.